Hello everyone. In this video we're going to explore the three key topics in ammunition design and function. First, what's the difference between an explosive and a propellant? Second, should the firearms industry be looking for alternatives to the propellant we use today? And thirdly, we'll dive into the three types of primers commonly used in ammunition: the Boxer, the Burton, and the battery cap. I'll show how each one of these works in very simple drawings. Explosives and propellants are both energetic materials, but they behave very differently. An explosive is designed to release energy very quickly, usually in the form of like a shock wave. This kind of rapid release is called a detonation. It is used to break things apart, not move them forward. Think of C4 or dynamite. They're powerful, destructive, and fast. On the other hand, a propellant burn is a more controlled way. It releases gas over time, not instantly. That gas pressure is what pushes a bullet down the barrel or lifts a rocket into the sky. Smokeless powder is a common example of firearm propellant. It doesn't explode, but it burns rapidly but steady. So in short, explosives equal sudden destruction, and propellants are controlled propulsion. Let's talk about modern firearm propellants. Should the firearm industry be moving away from the propellants we use today? In my opinion, yes, we should be looking to make at least some improvements. Many current propellants and primers still contain toxic materials like lead and other heavy metals. This raises some health concerns, especially at indoor ranges, and also including environmental concerns when it comes to long-term exposure. Also, some propellants burn very hot, which can wear out barrels faster, especially in high-performance rifles. So what could we use instead? Researchers are working on a lead-free primers and clean burning powders. Some new formulations use nitroglyceride, which burns cooler or eco-friendly, that breaks down less toxicity. There's even research into electric ignition systems and advanced solid-state propellants. Though we are a long ways off from these becoming mainstream, there's still a hope. So, while classic smokeless powder still works, there's definitely room for improvement in safety, consistency, and sustainability.
Now let's talk about primers. Primers are small but critical components. They sit at the base of the cartridge, and their job is to ignite the propellant when struck by the firing pin. There are three major primer designs that we will look at: the Boxer, the Burton, and the battery cup. Let's walk through each one. Firstly, we'll go over the Boxer. The Boxer is the most common in the US and is extremely reloader friendly. Inside the primer cup, there is a small metal anvil and a priming compound. When the firing pin strikes the cup, it crushes the priming mix against the anvil, causing it to ignite. A single flash hole in the center of the cartridge base lets the flame pass through and ignite the powder. Because it has only one central flash hole, spent Boxer primers are very easy to remove and replace, making it extremely popular with reloaders. Next up is the Burton primer. This one is more common in European and military surplus ammunition. In this design, the anvil is built into the cartridge itself, not the primer. There are two or more small flash holes instead of just one. The primer cup contains the only priming compound. When struck, the compound ignites against the fixed anvil, and in the case, the flame travels through the flash holes and to the powder. This design works well, but is harder to reload because of the built-in anvil and multiple flash holes. Finally, we've got the battery cup primer. This is typically used in shotgun shells. It's a larger primer that consists of an outer battery cup and an inner primer cup and a built-in anvil. The whole unit is self-contained, and the primer is sealed with a disc to prevent moisture and debris from getting in. When struck, the primer ignites and the flames pass through a vent into the main power charge. The battery cup design adds strength and support, which is important for larger diameter perimeters like those in shotguns.
So to recap, explosives and propellants may look similar, but they behave very differently. The firearm industry has a good reason to look into safer, cleaner, and more consistent propellant options. And there are three main types of primers, each with its pros and cons.